In the previous video about systems and word problems, we looked at a situation and only found the solution. In this video, not only are we going to interpret the situation in terms of functions, we're going to use function notation, and we're also going to look at the meaning of the solution. Now, I've worded these questions in a way that it would appear in a more realistic situation. And so therefore, we're going to have to interpret before we can solve anything. Let's look at the situation. Fred went shopping at the mall for Christmas gifts. He arrives with 400 Omani Rials and spends 15 Omani Rials per hour. Gary is working at the mall and will be paid for his work today. He came to the work with 20 Omani Rials. He gets paid 7 Omani Rials per hour. The function that represents the money that Fred will have at any given hour spent shopping at the mall is f of x minus 15x plus 400. The function that represents how much money Gary will have at any given hour while working at the mall is g of x equals 7x plus 20. Notice in the function notation, I have named this function f of x, which gives it a unique name other than just y equals. In the calculator, we call this y1. This function g of x, I've chosen g of x because it relates to Gary. This function represents what Gary will make, and in the calculator, that is y2. So you can see that on paper we can name it one thing, and we might have a function given to us in a certain name, but in the calculator we have to remember that the calculator will only take a y as an equation, not f of x as a function. But it is still a function the way that we write it in here. In fact, our calculator doesn't really graph equations that aren't functions. There's other ways around it that you can interpret, but we're not really going to be concerned about that this year. This year, if we use our calculator, we're using functions. That doesn't really help us that much for this equation. We don't really need to know that, but it's good to keep it in mind that when you graph on your calculator, it should be a function. Now, let's look at the first question. How much money will Fred have after 5 hours at the mall? And I underlined the 5 hours and said input. This is a little note to myself to remind me that 5 hours represents the input for the function, which is f of x. And this is how I write the work for finding a value of a function. This is called finding a value for the function. A value represents the output of a certain input. In this case, the input is 5, and the output will be the amount of money that Fred has after 5 hours of shopping at the mall. So, using the calculator, before I find the value, I'm going to make sure that for this, the value or the input will be on the calculator, just so that we can see the value. You can see that I have adjusted the y max. It looks like it's standard, except the y max is 410 in order to accommodate this 400, the input of, or the output, the y-intercept of 400 for the situation. So we can do calculate the value, and the value is, the input is 5, and the value is 325. So writing it in terms of the situation, Fred will have 325 Omani Rials after shopping 5 hours. All right, let's look at the next situation. How much money will Gary have after shopping or after working for 5 hours at the mall? So now, instead of using the function negative 5x plus 40, we're going to use this function, which is 7x plus 20. Now notice we can see both functions on the window, and we can see that the input of 5 is here. Now instead of going through the whole process of second, trace, calculate to find value, we can just push the down arrow, and you can see that it'll switch to the other function, the other equation, and you can do that all day. Whoop, y1, y2, f of x, g of x, f of x, g of x. It's really fun. All right, so we can see here that the value for an input of 5 for my second function, g of x, is going to be 55. So Gary will have 55 Omani Rials after working 5 hours. All right, next. At what hour will Fred and Gary have the same amount of money? This is the solution to the system. Solution to a system is the output and the input is the same for both equations at the same time. So we are basically looking for the same input, the input of the solution. But of course, we're going to have to find the solution anyway. Looking back to our graph, notice that our window needs to increase in order to accommodate the solution. And so I'm going to go to the window, and since this is 10, I'm going to go ahead and increase that actually to, let's see here, how about 25? Perfect. We have the intersection on the window, so we know that we can find the solution. So, second trace, which will give us calculate. Intersect. The first curve is our first function, enter. Second curve is our second function, enter. And this is close to the intersection, and here we have the intersection. Let's go ahead and write down the solution. 17 and 27 hundredths. I'm going to write that down here. 17 and 27 hundredths, comma, 140 and 9 tenths. So I get that number, 17 and 27 hundredths, that's the input, and 140 and 9 tenths. That is the output. I'm going to put this aside because we need to interpret this in terms of situation. At what hour? This is the input. That will answer this. They both had 140 Rials after 17 hours at the mall. Now, regardless of whether this is, you can decide whether this is significant or not. Right now, Gary and Fred both had 140 Omani Rials and 900 Beza after being at the mall for 17 1/4 hours. You can see here that I interpreted this as 1/4 because it's 0.25 or 25 hundredths. That is 1/4. So that makes more sense to say 17 1/4 hours, because in everyday language we don't say 17.25 or 17 and 25 hundredths of an hour. We say 17 1/4 hours. So it's important that when you're interpreting the situation, You will look smarter and like you know what you're doing if you actually say it in the most realistic English use of the situation. How many hours can Fred shop in the mall if he doesn't want to take more money from his account? Let's look at the graph, and we can see that this will be right here, the intersection will be where Fred will run out of money. This is the y-intercept. This is what this means. So Fred will run out of money. Now, this is going to be a 0. We need to find the 0, and so I'm going to do that in part 2.